طيب, Assalamu alaikum everybody. Today we are going to continue our last lecture, which was about the weathering. Remember, we defined the weathering as the process that breaks bedrocks into smaller rocks and minerals fragments, and eventually is going to develop to be a soil. And we know that soil is very important. Okay. And also we said that we have physical weathering and we have chemical weathering. Anyone can remember the difference between physical and chemical weathering?
For physical weathering, the material will stay the same. It will separate, the two parts will be the same.
Yes, excellent.
For chemical, it will change the properties of the material after it's being affected by the chemical.
Yes, that means the old minerals, it will be replaced by new minerals. Okay, so very good. And also we discussed the physical weathering. We said that there are 4 ways in which the physical weathering could take place. Do you remember the 4 ways? Anyone here?
Yes, freezing of water and crystallize and aberration.
Crystallize of what?
Solid. It's coming from solid.
From salt.
Salt, yes, sorry.
And is a way number 2. So way number 1 is freezing and thawing. And way number 2 is the formulation of salt crystals.
Yes.
And way number 3 is
aberration.
The aberration was the 4th way or the 4th reason.
Penetration of tree.
Penetration by plant roots. The roots of the tree is going to make some kind of physical weathering. So today we'll continue from where we left off last time. So we discussed the weathering itself. We discussed the difference between the physical weathering and chemical weathering. And also we'll talk about in the ways in which the physical weathering is going to take place. And we said that the freezing of water is just like we said that the rocks contains voids and spaces inside it, and the saturation of the water, which means that the water will try to get inside that voids, and if the rocks is exposed to freezing conditions, there is do you hear me clearly?
دكتور في صدى في حد مشغل المايك وعم يطلع صدى مزعج.
Yes, please make sure that you turn off all of your phones. Do you hear me right now clearly?
Yes, yes.
Yes. So I was saying that the freezing, we know that inside the rocks we have spaces. So the water might get into that spaces and that voids. And if the rocks is exposed to freezing conditions, what will happen to the water? It will turn to ice, and we know that the volume of the ice will try to make some kind of the tension stresses because the volume is going to be bigger than the liquid water. And as a result, we will have physical weathering. The other reason, which is the formulation of salt crystals, we know that we can find salts from seawater or from some kind of groundwater, and if we have exposure to seawater, or we have exposure to groundwater, when the water evaporates, it will leave the salt crystals, and salt crystals will try to enlarge the cracks. And for number 3, the penetration by plant roots. We know that some trees might grow up inside some of the cracks inside the rocks. So the grow up of the roots, it will cause some kind of physical weathering. The 4th reason, which is abrasion. We know that the loose sediments, it could be carried out by wind or water or by ice. And in order for loose particles to move from one place to another, some kind of friction with the rock will take place. And as a result, we'll lose the surface of the rocks. So today, we are going to talk about the chemical weathering. So we know that the chemical weathering is a complex process. Why it's a complex process? Because we are going to have new minerals out of the original minerals, which make it very complex. So chemical weathering involves complex processes that alter the internal structure. The internal structure is going to be altered. Why? Because we have new minerals. And during this transformation, the original rocks decomposes into substances that are stable in the surface environment. And also, very important point, we need to know that the new minerals is going to be stable. Okay, and the process itself after we get new minerals is going to be stable, which means that it's not going to change to any kind of minerals. And in order to have the chemical weathering, we need to have very important agent, which is water. Okay, why do you think the water is very important? Why the water is very important in the chemical weathering? Anyone can get the answer?
It will speed the reaction, or it has oxygen in it.
Yes or no? I need a clearer answer. Specific, more specific than that.
It will speed the oxidizing process.
How?
Because it can dissolve minerals.
The water can dissolve minerals?
Yes.
How? How the water is going to dissolve minerals? Because the water can move from one place to another, right? So the water itself, it has the ability to move from one point to another. If the water has that ability, that means it can carry ions from one point to another. If the water is going to do that, that means it has the ability to cause chemical reactions. Okay, so water is by far the most important agent of chemical weathering. Although pure water is not reactive. That means if you have a water that does not have any kind of ions, it's not going to make any kind of reactions, chemical reactions. Okay, what makes the chemical reaction is that a small amount of dissolved minerals it's needed to activate it. The water alone will not be able to cause chemical reactions. In order to be activated, we need to have a small amount of dissolved materials. Okay.
Doctor,
So
do you mean like seawater?
Yes, yes. Without the water itself, it will not be able to carry the salts or any kind of ions.
Mm-hmm.
Okay. So we are going to see common reactions involve the water. Okay. So we have oxidation, and we have carbonic acids. We know that the oxidations, we know that when we have iron or steel, and if the iron or steel is exposed to water on cycles, what do you think will happen to the iron or the steel? Anyone can remember what will take place?
It will rust.
It will rust, yes. We all of you know this. So chemical weathering, we talk about this point. We say that we have oxidation and we have carbon acids. The oxidation with itself, everyone has seen iron or steel objects that have rusted when exposed to water, right? All of you saw something like that. When you have steel or you have something that contain iron, when it's exposed to water, we will have rust or it will rust. Okay, and the same thing can happen to iron-rich minerals.
دكتور
So
الرصد
if
اللي
you
هو
have
الصدى صح؟
granite, yes, if you have granite rock like this one, and if you know that granite it has it contains some kind of iron. So when the granite rock exposed to water, you see what happened to that part here? this part here. What happened to that part?
دكتور السلايد اللي عندك يختلف عن اللي عندنا.
Oh, no, I'm talking about the one which is presented right now. Do you see this one?
Yes, yes.
So what happened to that part, the outer part? You see, you can see, right? some yes.
Became rust.
Yes. So because of the water and because of the granite, it has iron minerals in it. So we have rust. And also the process, it could take place in a large quantities, like this one here. You see these mountains here?
No.
So this mountain here, it has iron minerals inside it. And if it's exposed to water, it could be from groundwater or it could be from rain. So we'll have a rusty brown color, which is will change the iron minerals into iron oxide or iron hydroxide minerals. So oxidation, it takes place mainly because of the water, and also we need to have a percentage of iron inside the rocks. Okay, is that point clear for everyone here? Does it make sense?
Yes, it's clear.
So let's move to the next type, which is carbonic acids. We know that we have in the air, we have CO2, carbon dioxide, right? And if you have a rain and you have a large amount of carbon dioxide, what do you think will happen? Anyone can guess what will happen?
Again, excuse me, doctor.
Okay.
The rain will be acidic.
So yes, the rains will try to dissolve the CO2, and it will cause, and as a result, we will have carbonic acids, right? So when carbonic dioxide, CO2, is dissolved in water, it forms carbonic acids, H2CO3. And rain dissolve some carbon dioxide as it falls through the atmosphere. Okay. Also, we can find another type of or another source for carbon dioxide. Inside the Earth itself, we know that the decaying of organic matter. As a result, we also will have CO2, right? And if we have a water go through the soil, it will mix with carbon dioxide, and also we will have carbonic acids. So we could have carbonic acids because of the rainfall, plus if we have CO2 in the air, or we could have carbonic acids from the soil, because we know that the organic matter, the decomposed organic matter, plus the water, it will form the carbonic acids. So an additional amounts released by decaying organic matter are required as the water percolates through the soil. Percolate and you go through the soil itself. So acids such as carbonic acid readily decompose many rocks. And for example, remember the calcite, right? So the calcite is very important in the building process, because we use stones from marble and limestone. And the mineral calcite is easily attacked by even a weakly acid solution. So even if the solution it has lower concentration of acids, it will attack the calcite, even a small amount of it. So in nature, over a period of thousands of years, large quantities of limestone are dissolved and carried away by groundwater. So the carbonic acids, we have many sources, or actually we have two sources in order to form carbonic acids. Is it from the rain plus CO2, or from water inside the soil with CO2 again? And if this one attack the calcite, especially the calcite, it will dissolve the calcites, and even sometimes carry the calcite away using the groundwater. Any question regarding this carbonic acids? Does it make sense for everyone here? or it's
Yes.
needs further explanation?
Yes, clear.
So
Yes, please.
as you can see here in this cave, the acidic waters create these caves here. Okay, mainly this cave is made from calcite. So if we have acidic water, we will have some kind of this shape here. So dissolved power of carbonic acid play an important role in creating limestone carving. Carving means the chambers inside the cave, like this one. Okay, this image from some kind of cave in Croatia. Okay, so acidic water is very powerful. It can dissolve many kind of rocks, especially the rocks that contains calcite. So any question regarding the chemical weathering? We say that we have oxidation and we have carbonic acids, and the water is very important agent in order for this reaction to take place.
Doctor, excuse me. When the acid, the carbonic acid, would dissolve the calcite, that's the image that you just saw us is the result or what? I didn't get the
Yes,
point of
the result for that. Yes.
Mhm.
So if you have
Thank
a
you.
mountain, you have a mountain made from calcite, and you have groundwater, and that groundwater it mixed with some kind of carbon dioxide, then we will have carbonic acids. And as the groundwater move inside the mountain, it will create some kind of caves like the one you are seeing right now. Does it make sense for you right now?
Yeah, it does. Thank you so much.
Any question about the chemical weathering, oxidation, and the carbonic acids? Okay, if it's clear, let's move to another topic, which will talk about how the soil is going to be formed. Okay, so now we finish from the weathering, and we're going to open soil formation.
دكتور ما ارسلت لنا هذا الليكتشر.
Okay, because sometimes I make modification. Like you see last time, I make some kind of arrangement which facilitate the understanding.
Yes,
Okay.
yes, okay.
So sometimes I find some information which is not necessary, and sometimes I need to put some pictures and some information will help you to understand. Okay, so that is why sometimes I delay the sending the lectures. Okay, it's for your own good. So today we'll talk about the soil formation. Anyone can guess which is the process help to forming the soil?
Physical weathering.
Physical and chemical weathering in general, right? So we said that the last or the final result of weathering is to form soil. So soil is very important. Civil engineers, we deal with soil a lot. And I think next year you are going to take something called soil mechanics. So we are going to deal with the soil in greater details because soil is very important. So we need to know what does it mean by soil. So the geologists, they have a definition for the soil. So when they say this one is the soil, that means they are describing layers of materials. When we say this material is soil, that means we are describing layers of materials. Layers of materials with conditions. The first condition is it should be happen as a result of weathering. This is the first conditions. So initially created by breakup of rock during weathering. Also, it should experience addition of new materials and experience losses of original materials. And the last condition is we will go through modification. from physical mixing or from chemical reactions. So when we say soil, that means we have layers of materials with I think with 4 conditions. The first one, it should be as a result of weathering, and we should have additions of new materials and losses of original materials, and also we'll have some kind of modification through chemical reactions or through the physical mixing. And we know that soil is one of our planet's most valuable resources. Why do you think soil is very important for us? Anyone can guess the answer?
Food. We can't grow food without soil.
At least
We can use it in concrete to make it strong.
Okay.
we
What
cannot
else
use
more
concrete
important than
without.
this one? Again?
Buildings depend on the strength of the soil.
Yes. What else? Okay.
It's very
so
important source for us as a civil engineer, especially as a civil engineer, and in the engineering as a general.
In general,
Mhm.
for humanity, do you think soil
Yes.
is very important?
Of course.
Why? Why?
To grow plants.
Yes, we already mentioned this. And what else?
We live on
will
the
you
soil.
be able will you be able to raise animals without soils?
No, we cannot.
We cannot. So for humanity, soil also is very important in that perspective, right? So without it, there could be no agriculture, like you already mentioned, no forestry, which means that we are not going to have any kind of forest, no ranching. Ranching means that raising of animals in large lands. Also, we're not going to have home gardening, right? So soil is very important for humanity. And as civil engineers, we know that in order to build any monument or any building or something like that, we need to deal with the soil, because if we have weak soil, it may cause failure for the building. Okay?
Yes, and also we use it in cemetery.
What do you mean by cemetery?
المقبرة دكتور قبر.
Yes, yes. In order to decompose the bodies, right?
منها وإليها دكتور.
Okay, so soil is combination of minerals and organic matter, water and soil. So mainly the soil composed of 4 components. We need to have air, we need to have water. Both of them represent 50%, 25% for air and 25% for water. And the largest portion is for minerals, matter, which is 45%. And while the 5% is organic matter. So soil, when we say soil, that means have combination of minerals, matter, organic matter, we have air, and we have water. And when we say that organic, we know that what does it mean by organic matter? Anyone know the answer? I think we already discussed this, right?
Doctor,
In the previous
the animal, when the animal dies or the bio dies,
living part of the earth.
yeah, it dissolves in the sand or in the soil, and this is the organic matters, which is 5% that we mentioned.
Yes. So organic means coming from living organisms, right? So organic matter in the soil come from the remaining and the waste products of planet, animals, and other living organisms, like you just mentioned. So do you think we have the same kind of soil everywhere?
No.
Well, no, definitely not.
Of course, it will be different.
Why?
No,
Why?
different.
There is a red soil.
organic
There
matters.
is yes.
Why?
It depends
why?
on the organic.
Well,
the
but
organic
you
of
say
the
that organic represent only 5%.
Well, also the minerals will be like have different composition of minerals and water and organic matters.
Why we should have different kind of minerals? Due to what?
Due
maybe
to the
Different weathering?
map where you
and
I think
placed on tectonic
due
plates, maybe
the,
it's
the location, due to
divergence.
the area.
From where we can get different kind of minerals?
You have different type of rocks.
Like if we are
from where we can get minerals for the soil?
Volcanoes, right, sir?
from the weathering
And the weathering from what? From the rock, right?
yes. The rock contains minerals.
Yes, so we get minerals from rocks. Okay.
Mhm.
And will we have the same kind of rocks everywhere?
No.
No. So if
Definitely
we have different types of rocks, that means we will have different types of minerals. And the soil is not, the soil is going to be different everywhere, right? So soil differs. Why? Depending on what types of rock, okay, came from. So we need to talk about how the soil is going to develop. We have some kind of steps, like we need inputs of new materials. If you can look at that picture here, we have a portion for a soil here. So in order to have a soil, we need to have additions. Additions could be of new materials. So the soil, some kind of new materials will try to get into the soil. Also, we will have losses of original materials. So if you look into that system here, the minerals itself or the material itself, it could be lost from the soils. Also, it could be lost from the surface due to erosions. So we have inputs and we have losses, inputs or additions. Also, we'll have modifications. Some kind of modification will take place, either to be transformation or translocation. So we'll have modification through physical, mixing, or chemical reactions. When we say soil modification, it means that we have processes, and it can be divided into translocation and transformation. When we say transformation, it means that we have original minerals, it will change to new minerals, which means that we'll have some kind of transformation. When we say translocation, that means also, again, because of the water, it will carry the minerals from one point to another. So the movement of minerals through the layers of soils, we'll call it translocation. But don't worry, we'll talk about all of this in greater details. So soils, like many other components of Earth's system, can be described as geosystems. Why we can describe it like a geosystems? Because soil is natural features, like volcanoes, like groundwater, and if you have natural feature, that means I can deal with it like a system. Okay, so we will divide it into inputs and into processes and into outputs. Okay, so for example, to make it very simple, if you have computer, in order to work with the computer, you need to put inputs, and the computer itself, it will make some kind of processes, and it will give you results, which is outputs. So we're trying to deal with the soil in the same manner. Okay, so the inputs, it will be the weather, rock, organisms, and dust. So in order to have a soil, we need to have inputs. The inputs, it will be weather, rock, organisms, and dust. So the weather rock, the first one, we know that physical weathering breaks down rock into smaller pieces, and we have the chemical weathering transform minerals. So the weather rock, it could be from physical weathering or it could be from chemical weathering. If it's as a result of physical weathering, that means we'll have some kind of breakdown of rocks into smaller pieces. If we have chemical weathering, that means we'll have transformation for the minerals. We'll get new minerals out of the old minerals. We can see here, we see the weather rocks. like this one or this one or that one. We already cover this in greater details. The other one, which is the organisms. We know that the source of organism, the plants and other organisms, may colonize the soil, and it takes over the soils, and when they die, their tissues decompose to form humus. So we'll give it a name. When we say humus, that means the remaining of the planet and other organisms, the decomposed tissues, like this one here. Okay, we know that the soil, it has many organisms live inside it, and when they die, the remainings, we'll call it humus. Okay, so as inputs, we have weather rock, and we have organism, and we have dust. Dust doesn't need any kind of explanation. Dust is obvious, right? So anyone has any answer about the inputs, the weather rock, organism, and dust? Does it make sense for all of you?
Yeah, okay, it does make sense.
Okay, let's move to the processes. Remember, we say that the processes, it will be divided into transformation and translocation. So we'll start with the first one, the transformation. As soil ages and matures, the materials, it could be addition or could be losses, so added to or removed from, undergo a set of transformation. So we know that when we have the soil in the initial stages, as the soil grow up, we will go through some kind of transformation. So the addition of humus, for instance, provide a source of nutrients that encourage further plant growth. And if we add more humus, that means we have a positive feedback processes within the soil geosystem. So the transformation, that means new materials will get inside the soil, and it will make some kind of processes. The simplest example, the humus, we already defined the humus. The humus will provide source of nutrients, which means that it will help in order to move on many processes. Another obvious example, many soil transformation involve chemical weathering of feldspar. Remember the feldspar from the minerals lectures? Remember
yes,
the feldspar?
silicate.
Yes.
It's we remember.
Some kind of silicates. So during the transformation process, the feldspar and other minerals may form to make clay minerals. So the feldspar, during some kind of transformation, it will convert into clay minerals. And this is an example for transformation that is going to take place inside the soil. So we have the inputs, the weather rocks, and the organisms and the dust. And now we are talking about the transformation. Transformation, because of the humus, it will provide nutrients, and that will help in many processes inside it. And also, we may have some kind of transformation. For example, the feldspar, if you have a feldspar minerals, it will convert to clay minerals.
Now, excuse me, what is clay minerals?
You don't know the clay minerals? From the sediments. Were you be present when we talk about the sediments? Okay.
I think not, but I studied it at home.
Okay. We already talk about the clay minerals, some kind of sediments or sedimentary rocks. So the other part is translocation. We talk about transformation. Now we need to talk about the translocation. We already say that the processes could be divided into transformation and translocation. When we say translocation, that we have movement, and it should be verticals within the developing soil. Of course, in order to have this kind of movement, we need to have water again. So water is the main agent of translocation, usually transporting dissolved salts. So again, the water will try to carry on some kind of ions. Okay, so when we say translocation, that means I have vertical movement. So water selectively removes some materials as it's infiltrate down. When the water of course, we'll have, if you have a water on the surface of the soil, as the water goes down, it will carry some kind of minerals, okay, through the soil after rainfall, and we call this process is leaching. So when we say leaching, that means the water could be from rainfall or any kind of source on the surface of the water. As that water goes down, it will carry some materials. We call this process leaching. So we have transformation and we have translocation. Transformation mainly means that some minerals may convert to another minerals, while the translocation, that means the vertical movements of the materials within the soil. Okay, and if the water carry materials, selective materials, as it goes down, we call this process leaching. So we will look at that picture here in order to summarize what we have studied today. We said that we have inputs and we have outputs, and also we have processes. So if you look right hand side, the inputs or the additions, we have organic matter, right? You see the organic matter here. When this one die, you see the leaves. This one, it will decompose, and as a result, we will have organic matter, and also we'll have airborne dust here, and also we have chemicals and minerals from bedrock as a result of weathering. So we have organic matter, we have dust, and we have weathered rocks. Okay, so this one is the inputs or the additions. On the other hand, we have some kind of losses. We have water erosions here. The wind also, it will try to take some amount of soil, as well as the erosion. We have the leaching process. We say that the leaching process, as a result of water, when you have a water as a result of rainfall, as the water goes down, it will carry some kind of minerals, and we call this process leaching. So leaching, it could be it could be classified as some kind of losses. And the leaching process itself, it will take place because of something called translocation. So inside the soil, we have two processes. We have transformation and we have translocation. Transformation, we said that such as feldspar are transformed into other minerals such as clay. So if you have feldspar, and as a result of what's going on inside the soil, and you get clay, we call this transformation. Also, some minerals such as carbons precipitates from fluid within the pore spaces of the soil. So as a result, I will have some kind of salts. So also this is going to be classified as transformation. On the other hand, the translocation, the minerals, grain, and aggregates may move through the soil. So the movement, the vertical, especially the vertical movement of the minerals or the materials inside the layer of the soil, we call this one translocation. Okay, so transformation and translocation occur throughout the soil profile. So throughout all the soil profile, we'll have transformation and we'll have translocation. I think this picture here summarizes everything we have discussed. Okay, so I think I'm going to stop here. Next time we'll talk about the diversity between soil exists because the makeup of the soil depends on 5 soil forming factors. So we need to know the climate factors, and we need to talk about the parental material, and we need to talk about topography, and about organism, and about the time. These factors, it will explain to us why we have diversity in the soil. But anyone has any question about the soil as a geosystem here before we finish the lecture? Is it clear for all of you? Does it make sense?
Yes, it's clear.
Yes, Doctor. Yes, thank you.
Okay, I hope you enjoyed this lecture. Inshallah, I'll see you next time to continue.
بس تحضرني بس.
Okay, no problem. Anyone has any kind of questions? Is it clear for all of you?
It's very clear.
Thank you.
It's clear.
تاكسين.
Okay.
Yeah, it's clear.
Okay.
قفل دكتور. قفل.
Okay. Any questions here?
Doctor, did you take attendance?
Yes, yes. I will take
Did
that.
you take-
Just I want to make sure that you don't have any kind of question. Okay.
No,
so
thank you.
I need
So
to
far,
finish
so good.
the recording.
Okay, no problem. See you,
Okay.
Doctor. Have
Now,
a nice day.
what do you think is better, the live lecture or the online lecture?
والله the live lecture دكتور.
لا دكتور معك دراسة.
Live
can see
lecture is
Doctor,
better, right?
anything?
على حسب المادة دكتور.
Yes, it depends. If for this course, I think because of most of it is theoretical, so online lecturing is not that bad, right?
رجعونا الجامعة
Yeah,
بس يا دكتور أحسن.
Yes, I agree.
The life is better.
Okay, I'm going
I really
to finish
like
the
it.
recording.